Okay, number one, they want me to use PMI, which is the principle of mathematical induction, to prove this formula, which says the sum of the integers from 1, I should say sum of the integers when squared, from 1 up to n. So 1 squared, 2 squared, plus 3 squared up to n squared would equal that formula they're giving me. And someone says, how do you proceed doing that? By PMI. So I'm going to do this by PMI. You can go to the whiteboard because I don't really have enough room to do that. And we'll do it on the whiteboard. Let me get the whiteboard up. And I'll just write the problem down again. Let me just scroll up, go on a scrap paper there. And let's write it down. So what are we writing down? Well, let's write this down. It's the sum. I equals 1 to n of I squared. That's shorthand, by the way. It's shorthand for 1 squared plus 2 squared plus 3 squared plus yada, yada, yada up to n squared. They claim that's equal to n plus 1, 2n plus 1 over 6. So what I'm going to do is start writing things down. And I'm going to write down, I'm going to get my eraser out, and I'm going to erase things that I don't really need anymore. I'll erase this. That was the shorthand. And I'm just going to say this is Pn. This is a proposition. So what I'm going to do is I'm going to just see if P1 is okay. Like, does that work out? Like the first integer. Well, what would you get? You would get 1 squared. That's the left-hand side. The right-hand side would be what? 1. And then 1 plus 1 is 2. And then 2 plus 1 is 3 over 6. Well, that equals 1. That certainly makes sense. All right, it's true for 1. Now what we're trying to do is we're going to try to write down pk. Now I know it's true for 1, but what I want to show is that 1 gives me 2, and then 2 would give me 3. So really what I'm trying to do is I'm trying to get this thing to move towards this thing. So let me write them down for you. And this is the tough part. So I'm going to write down 1 squared plus 2 squared plus, basically I'm writing the same thing down, plus yada, 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 up to, not n now, up to k. So I'll put down k squared. And that claim is that this would be the same thing as k plus 1, 2k plus 1 over 6. The big deal is, I wonder what k plus 1 would look like. Well, all it is, if I were to write k plus 1 down, it's 1 squared plus 2 squared plus 3 squared plus yada, yada, yada. Well, instead of stopping at k, I would stop at k plus 1 now. And what would the right side look like? It would look like k plus 1. Well, k plus 1 is k plus 2. And then what do you get over there? Well, that's more difficult, isn't it? It's 2 times k. Well, you still get 2k, but then you get plus 2 plus 1, which is plus 3, but over 6. All right? And here comes a problem. How do I go from pk to pk plus 1? Well, the one thing I noticed on the left-hand side, all you have to do is add k plus 1 to the left side, and it would look exactly like the left side and the other guy, the pk plus 1. Here's my problem, though. I also have to add to the other side. Otherwise, it would no longer be inequality. Well, let's write that down. What are you going to get? 1 squared plus 2 squared plus 3 squared plus yada, yada, yada. Well, I do have a k squared there, plus the next term up would be k plus 1 squared. Right. What I'm going to claim over here is that I got something. What do I have? This thing here is identical to this thing over here. But I'm looking at the right side. I'm a little bit concerned about it. I don't see it. Right, so I got to do some work over here. So I'm looking at these two terms here. And what I'm going to do is I'll get a common denominator 6. And I'll write it down. It's going to be k plus 1, 2k plus 1, plus 6k plus 1 squared. Well, I got to factor it. And what do you get? Well, the common factor is k plus 1. What are you left off with? K 2k plus 1 plus 6k plus 1. I still don't see it. So I got to keep moving. And this is the problem. I'm kind of looking at it, and I want it to look like that. It's partly looking like that, but not completely. I got the k plus 1. And then I got this business inside this grouping symbol. I got this business over here. Right, I got this whole thing over here. I'm kind of looking at it, and I want to just carefully look at it. And what would you get over there? Well, I would get 2k squared. I'll write that down for you. All right, 2k squared. I get k plus 6k, which is 7k. And then what are you going to get? Plus 6. All right? Now, by the way, I'm noticing I got a problem here. I'm looking at this over here. Again, I'm looking at it. And I'm wondering, does it equal this? Because if it does, I'm done. Let's take a look at it. If I were to factor that, let's see, k plus 2, 2k plus 3. It factors beautifully. You go over and check that, k comes, 2k is 2k squared. Then you get 6, let me see, I'm sorry, that's 6. 3 and 4, that's 7. Yeah, and you get 6 in the end. Works beautifully. This is done. Thank you.